Hey guys, in this video we're going to be talking about artificial languages. But first of all, let's talk for just a few minutes about what a natural language is. English, French, Spanish, Arabic, Chinese, Hebrew, Italian. Languages spoken throughout the world are known as natural languages. These are languages that evolve naturally through everyday communication between people over hundreds of years. These languages are complex, but they're also structured. Each has its own set of specialized vocabulary, grammatical structure, and syntax that distinguish it from another. Because these languages grew around human communication, they usually have both written and spoken forms. In addition, the formality of the language can vary by usage. For example, you probably don't talk to your grandmother exactly the same way you talk to your friends. Despite all their differences, one thing that natural languages have in common is their potential for ambiguity. Ambiguity makes natural languages a very poor means of communicating clear and precise instructions to be interpreted and executed exactly as intended. In short, natural languages make lousy programming languages. And as computer scientists, we need something better. Enter artificial languages. Unlike a natural language that develops gradually and informally among whole societies, artificial languages are usually developed relatively quickly by small groups for very specific purposes. And while they can be complex, just like the natural language you might use to communicate at home, they're usually much simpler and structured. Over the years, a number of attempts have been made to develop and popularize even a simple, universal, written and spoken language that could cross cultures and political borders. Esperanto is just one such attempt. To date, only about 2 million people speak it, most of those as a second language. For human-computer interactions, artificial languages designed specifically for programming include things like Java, C++, Swift, Python, BASIC, Pascal, COBOL, and Fortran. These languages are usually characterized by their textual nature. They use letters, digits, and punctuation typed into a computer with a keyboard. They use a certain set of keywords and punctuation to express each instruction in a form that can be interpreted and executed without any ambiguity. And I just want to show you a few examples of the varying syntax between different programming languages. So each set of these instructions will print the word hello. And you can see that there's 3 different ways of doing it in 3 completely different computer languages. But notice how even without knowing the language, even you don't even know what the special punctuation might mean, any English speaker finds these instructions fairly readable. Most keywords in these programming languages tend to be from English rather than from another natural language. And I want you to compare these to the way we've seen algorithms informally expressed throughout this unit so far. We're going to revisit textual programming languages later in Unit 4, Digital Media Processing, and you're going to get to try your hand at writing programs in the Python programming language. Well, let's talk just for a few minutes about something else. Visual programming languages. See, one of the biggest challenges in learning to work with textual programming languages is the problem of syntax. These languages are demanding about every little thing. If the programmer doesn't use the exact spelling, capitalization, and punctuation required by that specific programming language, then the computer won't do what you want it to do. To combat this problem, a number of visual programming languages have been developed. Visual languages allow programmers to drag and drop blocks or icons into organized blocks that represent the different parts of a program. Blocks-based programming tools automatically handle all the grammar and syntax the programming language requires. And this allows novice programmers to focus on the logic of their programs, rather than the syntax, spelling, and capitalization. The example here on your screen shows how individual programming blocks can be assembled in a language like Scratch. In Unit 2, Programming, you're going to build your first interactive programs using Scratch. I want to leave you with this definition or statement. Algorithms executed by programs are implemented using programming languages. So just know that any of our algorithms that we're going to create informally in our groups, we're going to express them through some programming language. Thanks for watching, guys. Y'all have an awesome day, and I'll see you in the next video.